This project was developed by our team for the subject of the selected topics in physics and focus on creating a prototype related to the Doppler effect and the simple pendulum. During the process, we compared our theoretical knowledge with hands-on practice, working towards to design test model that model observe this physical phenomenon. Teamwork is essential to better understand the concept and apply physics in a more dynamic and experimental way.
Hello, my name is Edson and I will talk about the introduction and the main materials of our prototype. Since ancient times, physics has helped us understand how the world works. In this project, we connected two interesting phenomena, the simple pendulum and the Doppler effect. A simple pendulum is an object that swings back and forth like a clock, or a hanging rope. It shows periodic motion and depends on the length of the string and gravity. The Doppler effect happens when a sound source is moving. The sound seems high when it comes closer and lower when it moves away. To make this sound practical, we built a simple prototype using a pencil. The pencil swings like a pendulum and plays a sound so we can observe how the frequency changes while it moves. This helps us understand physics in a creativity and real way. Now these are the materials we used. One pencil, a thin string about 30 centimeters long. Adhesive tape, a pony with a sound up or 10 generator, a stopwatch, a ruler, and a support to hang the pendulum like a table or shelf. The simple materials helped us build a prototype that shows both the motion and the sound change clearly.
Hello, my name is Omar. I'm going to talk about the simple pendulum. The objective is demonstrate how simple pendulum works in measure each period. The specific materials are pencil, straining rope or of 28.5 centimeters and adhesive tape. The steps is one, tie one end of the strike to the pencil, tie the other end to table or stand. Use the ruler to measure the length of the string for the trying point to the center of the pencil. Put the pendulum to the side about 10 centimeters and release it. Do not push. Use the stopwatch and measure the time of 10 complete oscillations. Divide by 10 to get the period. Formula is T and 2PLGT, where T is period, L is length of thirds in meters, G is gravity of 9.8 meters per second, Annex 2.1.
3. How to calculate a simple pendulum? The simple pendulum is calculated with the following formula. The total time between the number of complete oscillation. The data we have is 80 seconds, 75 complete oscillation. Now to the solve it, we first enter the formula with the substitute the data into the formula and solve it. We see that it gives us 1.06. This means the average period is 1.06.
Now the double effect. Objective is observe how the sound frequency change when the sound emit moves. The specific materials is a pencil, a cell phone with constant sound, another cell phone with an audio recorder. Step 1. One tape the cell phone emit the sound to the pencil. 2. Hang the pencil against with the stranger's pendulum. Swings it as the previous step. 4. While swings record the sounds with the other cell phone from fixed positions. The step 5 is listen to the recording. You will notice the sounds change as the pencil moves closer or further away. The explanation is the double effect occurs when a sound source moves relative to a linear. The perceived frequency change. The formula is F V O V plus Vs, where F is the perceived frequency, F is the emitted frequency, V is the speed of the sound in the air, VO is the observer speed, Vs is the speed of the source.
Listo. To calculate the perceived frequency, this is the Doppler effect. The first is the speed of the sound. Since we are using the pendulum, we need to know the period, which the time it takes to the one full oscillation. In the case, the average period was on 1.06 point. With the Pauli, we calculate the angular circuit. To the we use the formula says angular velocity equal to time divided p divided by the period, that is 2 times the 3.4 divided by 1.06 is the result the approximately fixed 5 the point neatly there radians per second. Next we use the amplitude of the pendulum, which was 15 centimeters. We convert with the meters, which the 0.50 meters to the find the speed of the source. We multiply the angular by the amplitude. That is 5.9013 times 0.15. The result is 0.889 meters per second. With the Pauli, we now apply the Doppler effect. Formula observed at rest. We take the mid frequency, which was 440 Hz, and multiply it by the of 1000, which in the case in the 140 meters per second, divided the 140 minute the speed of the source, which is 0.889. First, the extract there is 140 there minus 0.889, which give is the 100.1. When the divide 140 there by the 142 points, which is approximately 1.0026. Final, we multiply the result by the emit frequency for 140, and we get a perceived frequency of approximately 441.15 Hz. This shows how the motion of the pendulum causes a change in the frequency perceived by the observer, demonstrating in a practical way how the Doppler effect. In conclusion, this prototype can now as pencil pendulum. We combine the motion of the simple pendulum with a sound circuit to demonstrate the physical phenomenon. It is a practical visual way. When the pencil oscillates, it produces the behavior of carrying pendulum following its period, frequency, and acceleration to be analyzed. By including the sound, we can observe the Doppler effect, a shift in perceived
frequency when there is movement between the emitter and observer. This shift can be measured by comparing the emitting frequency with the recording by the fixed microphone. Thanks to more precise sensor or molecules, it is now possible to more accurately calculate the apparent frequency and the speed of moving object. Thus, this prototype not only explains key physics concept but also represents a essential creativity and education way to the connect theory with reality.